Welcome back to Applied Economics class. So we want to continue our interpretation of linear regression model coefficients. So here we want to see how to interpret level, also known as linear model. Okay. Let's assume we have a simple linear regression model which is um, at level. In the sense that we have none of the variable is log. So let's say we have y equals beta 1. So beta naught plus beta 1 x plus u. This is the population regression model. So let's say we have our estimated y, that estimated model. So let's say we have our estimated model as y hat equals beta 1 hat. So beta naught hat plus beta 1 at x I. Okay, where this y hat is the estimate of y hat. Okay, now and we have beta naught, okay, which is the estimate of the original beta. Then we have beta 1 here, the estimate of beta 1. Okay, so the interpretation will be based on the original model, which is the population regression model more the estimate. Okay, now how do we interpret this? Whether these variables are in units, such as maybe in dollars, kilogram, as the case may be, they may also be measured in percentages. Okay, now that tells us that there are different cases we can see as regard this. So let's consider this case one. The case one. This case one is where y, I, and xi are not expressed in percentages. Okay, they are not in percentages. Okay, they are in their original units. Okay, they are not in percentages. Okay, so how do we interpret? Okay, now the interpretation is very straightforward. So to interpret this, that is the interpretation. Bear in mind this condition that y and x are not expressed in percentages. So in that way, the interpretation is straightforward. So we simply imply that on average, this is the general interpretation. Anyway, general interpretation. You like that? General interpretation. It implies on average a unit that on average a unit change in x is associated with beta 1 hat unit change in y. Okay, that is the general interpretation. So what about what of if we know the direction, we know the sign of the estimate. So what of the situation whereby if we have, that is if beta 1 at is greater than 0, how do we interpret that? That if beta 1 is positive, that is y changes toward the direction of the change in x. That is, in other words, if x will fall, y will also fall. And if x should rise, y will also rise. That is the implication of that. So they move the same direction. So the direction of x, change in x will dictate what the direction of y will be. Okay. So if x should increase, that is, we have a positive change in x. So there is going to be a positive change in y. And if there's a negative change in x, there's going to be a negative change in y. So that is the case. Okay, that is the case. You can see it's very straightforward. Okay. So now we know that this is how to interpret that. Okay, now let's interpret further in order to make it clear. So, in other words, summarily, we are saying that if this is positive, so this coefficient is going to be interpreted as that because we consider the sign before the magnitude. Okay, we focus on the sign and the magnitude. So it's going to be that y is positively like yi related to x. Okay, and this on average a unit increase in x is associated with beta 1 hat unit increase in y. So because y will move toward the direction of x, okay, if beta 1 hat is positive, okay, so and vice versa. So vice versa here implies that on average a unit decrease. That is, if x will decrease in x, is associated with beta 1 hat unit decrease the same direction in y. That is how to interpret this. So especially if you have a level model and none of the variables is measured in percentage, this is the interpretation. So we continue with case 2 in the next video. Okay, thank you. Now let's look at let's look at a numerical example of this. So let's look at a numerical example of this. A numerical example of this. So I have that is a numerical example. So where we have your beta 1 hat greater than 0. So let's say we have where we have our beta 1 hat less than 0. How do we interpret that? That is, our beta 1 hat is negative. Okay, so interpretation, implies that x, that y has changes toward the opposite direction of the change in xi. So because this is negative, so the direction of the change in the dependent variable, which is y, will be the opposite to that of xi. Okay, that's the interpretation. So in other words, in this case, if x should increase, so y in this case will fall, and if x should decrease, y in this case will rise. That is the implication of this. So in other words, we will have this case. So the interpretation is going to follow this pattern, that y is negatively related to xi. In other words, on average, a increase unit increase in x is associated with beta 1 hat unit decrease opposite direction. Okay, decrease in y hat. You can see when x increases on average, that's a unit increase in x, is associated with beta 1 hat unit decrease in y. So because this coefficient of x, which is beta 1 hat, is negative, so interpretation will follow this pattern. Okay, and vice versa. And vice versa. So vice versa here implies that if you have that is on average, a unit, that is 1 unit, decrease in xi is associated with beta 1 hat unit increase in y. Okay, so that is the interpretation. Okay. Now let's look at so this is how to interpret this. Now in the next video we are going to look at the numerical example of these two cases. Okay, see you in the next video.